Hi there. In this video we're going to talk about bonding. So all atoms, except the noble gases, react gaining or losing electrons or sharing electrons. So there are three main ways for atoms to bond. One, metallic bonding. Now we're not going to talk too much about this, but this occurs between metals. So this is metal to metal bonding, metal to metal. Then we're going to talk about ionic bonding, which is the main focus of today's or this video, ionic. And this occurs usually between a metal and a non-metal. So the majority is a metal and a non-metal. And then three is called covalent bonding. And this is between a non-metal and a non-metal, which we'll talk about in later videos. So today our focus is on ionic bonding. Okay, so we're going to talk about ionic bonding. So ionic bonding, as I said before, is between a metal and a non-metal. Importantly though, it involves these things called ions. Now if we remember back to ions, so ions form when atoms lose or gain electrons. When atoms lose electrons, the atom becomes positive or positively charged, which we call a cation. If atoms gain electrons, they become negatively charged, or we call these anions. If you remember also, in a periodic table, all the metals in the periodic table form cations, and all the non-metals form anions, negatively charged particles. So we have these positively charged atoms, these cations, and these anions forming these bonds. So let's go through a couple of examples. So if we were to mix lithium and fluorine, if we look at our periodic table, we will see that lithium has an atomic number of 3. Fluorine has an atomic number of 9. Electron configuration of these, okay? Well, we know the number of electrons is the same as the number of protons, which is what the atomic number tells us. So this will have an electronic configuration of 2, 1, and fluorine will have 1 of 2, 7. Okay, so we have a metal, lithium, right? A group 1 metal, and then we have a non-metal here, a group 7 non-metal, fluorine. Let's draw these together. So, lithium, right? We're going to draw it 2 electrons in its first shell, 1 electron in its outer shell. Fluorine, I'll draw down here. We have 2 electrons in the first shell, and then 7. Notice I'm using dots now. This helps us differentiate between the electrons that get transferred during an ionic bond. So, when this forms an ion, this will lose that electron, and it will become this here, so Li, it will become that. It will become positively charged, +1. Fluorine will gain that electron. So this gains this electron. If we mix these together in the right conditions, these will react because this will lose this electron and it will give it to this one. So this fluorine atom gains that electron. So this now becomes, I'll do that here, next to it here. So we have 2 electrons in the first shell, 7 there, but because it's gained that electron, we draw it like that. Now it's got 1 more electron, so it becomes negative. So this atom now, so lithium, overall is positively charged, and fluorine here is negatively charged. This positive and negative forces attract, forming strong bonds, and that's our ionic bonding. So the ionic bond is that force of attraction between the positive and the negative. How it becomes positive negative is by that transfer of electrons. So that's how we're going to represent our ionic bonding. Let's have a go at one more example. Okay, so let's do beryllium, the group 2 metal that has an atomic number of 4, so that will form electron configuration like that. And let's join that with fluorine again. Let's do fluorine. I like fluorine, which is group 7, so that has 9, and it'll be the same as before, 2, 7. We can draw them out exactly the same way as before. So beryllium, this time, has 2 electrons, right, in the outer shell. Fluorine is exactly the same as before. This one's a full outer shell. It's easier to lose 2 than to gain 6 for this second shell. So this loses 2 electrons. Right, so this becomes beryllium. It looks like this. And that is, because it's lost 2, becomes 2 plus. Fluorine, as before, gains an electron. Now it can only gain 1 electron, but I have given up 2. So that's interesting. What do you think is going to happen? I'll just draw this ion out first. So we've got fluorine. I have to draw it small, sorry, running out of space. So that can only gain 1. So that becomes -1. I've still got this spare electron. What can I do? Well, I can use another fluorine atom, because it's got another fluorine atom's got another space. When we mix these chemicals, it's not just one of each atom, there's lots of different atoms. So we would do another one. Here we go, so there's all my electrons, and that second electron is now there. So I've got 2 positive charges here, I've got 2 negative in separate atoms, and that gives us our bonding there. So the formula for this atom actually becomes beryllium fluoride, or BEF, because there's 2 Fs, we know we have to use a subscript to say there's 2 Fs, BEF2. And there's an ionic bond involving more than 1 atom. Have a go at the summary question, and I'll see you soon. Thank you, bye.